Hello everyone and welcome to another episode of Kelly Telly. We're going to be continuing today with the overall topic of nuclear reactions, and specifically today we're going to be talking about radioisotopes and half-life. So those two words you probably wouldn't have heard before, except maybe in reference to some sort of video game. But I'm going to break them down for you, and then hopefully you have a little bit more of an understanding. So let's get started. So the first word I want to introduce today is the term isotope. Now, an isotope is a word that you may have come across earlier in the term. I may have mentioned it once or twice in class. And an isotope is quite simply atoms with the same atomic number, but a different number of neutrons. So if you'll recall, the atomic number is the amount of protons that an element has, and the amount of protons is characteristic for a certain name that we give an element. So for example, we can talk about the atom hydrogen. It has the atomic number of 1, meaning it has 1 proton. Now, an isotope is, so say we had 2 atoms of hydrogen. Not sure if I can draw on here. Let's have a go. So say we had hydrogen, and that is the atomic number 1. And then we have an atomic number 1 hydrogen here as well. But this one has, obviously, its mass number, oopsie, it's not 0, it's actually also 1. Its mass number is 1 as well. And this hydrogen, though, has a mass number of 2. Now, you remember the mass number is the amount of protons plus neutrons, so it's the mass of the nucleus. Now, what an isotope is they're atoms with the same atomic number, right? So both these are hydrogen because they both have 1 proton, but they have a different number of neutrons, and it's actually the neutrons that are different. So the atomic number is going to be the same, so it's not the protons that are different, and the only thing that can be different in the mass number then is going to be the neutrons. So we have these things called isotopes. Now, every element has a stable form of a stable isotope, right? Now, in this case, this hydrogen here is the stable one, and this hydrogen here is the unstable one. Okay, so we're going to introduce this new concept now called radioisotopes. Now, radioisotopes are a little bit different. You might just be able to connect the dots. So first off, they are an isotope, but they have one other property, and that property is that they are radioactive. Now, if you remember back to yesterday's lesson, what does radioactive mean? Well, radioactive means that it has an unstable nucleus and it goes through radioactive decay. Okay, so it has an unstable nucleus and goes through radioactive decay. So what that means is that one of these isotopes, right? Not particularly with hydrogen, but we'll go through some examples later in this slideshow. But if one of them was a radioisotope, it would mean that it is undergoing radioactivity. Now, it's kind of a hard concept to understand isotopes in general, so I just want to make sure you get it. So I'm just going to go through it one more time. So an isotope, an isotope is when we have an element that has or an atom that has the same number of protons, the same atomic number, but a different number of neutrons. Okay, and we call that isotope a radioisotope. If it is radioactive. And just remembering what radioactive means is it has an unstable nucleus and it goes through radioactive decay, meaning it will try and change itself to become this stable isotope. Okay, and we're going to learn later in this week how it can do that. All right, let's have a little bit of a look at let's look at Half-life now. So Half-life. Half-life is a concept that helps us explain the ratio of why certain elements break down. Sorry, not why, but the time frame in which certain elements go through this radioactive decay. So half-life refers to the rate at which nuclear decay occurs. The half-life of an atom is the time it takes for half of the nuclei to decay. So let's just break all that down. So the half-life, the reason we call it the half-life, I mean, you can kind of get it from the name, but it refers to the rate at which nuclear decay occurs. So it's the rate at which nuclear decay occurs. We measure it by half of an atom being decayed. So the half-life of an atom is the time it takes for half of the nuclei to decay. Okay, we'll come back to this. I think it's easiest to understand from an example. So let's have a look at an example. So example number 1, thallium-208, and we just a little quick aside is that we name elements like this. This is the mass number here. Okay, so this is the mass number here. And so if it is an isotope, if it has lots of isotopes, we'll write the name of the element, then do a little dash and write down its mass. That way it can help us to identify what isotope it is. So this is thallium-208 and it has a half-life of 3 minutes. Now this is the example here. If I have 6 atoms of thallium-208, how many would I have after 3 minutes? Now, I kind of wanted that to pop up, but the answer is you have 3 left after 3 minutes. Because after 3 minutes has passed, 3 minutes, you're going to, half of them would have decayed because that's what the half-life means. It means after that amount of time, half of the atoms of thallium you have in a sample are gone. Okay? So again, going back to our definition here, the rate at which the nuclear decay occurs, but it is specifically the half-life. This is the most important part. The half-life of an atom is the time it takes for half of the nuclei to decay. So for half of the nuclei, or half of the, if the nucleus decays, then it's not going to be that exact element anymore. And we'll go over that in later episodes, but you should see that. So for example, thallium has a half-life of 3 minutes. After 3 minutes, half is there. Oops, half is there. If you did it again, right, now you have 3. After 3 minutes, how many more would be left? Well, there'd be 1.5. However, we don't really do 0.5s because obviously it exists as a whole. So it could be 2, could be 1, right? That's how we work out half-lives. If you were to get an example in an exam, it would be a nice clean number. So it would be like 6, you have 3 left over. It could be, if I have 1,000 atoms of thallium-208, how many would I have after 3 minutes? You'd have 500. All right, let's look at another example. Example. An element starts with 100 atoms, and after 5 minutes, there are 50 atoms. What is its half-life? Well, its half-life is going to be the time it takes to reach half. As we started with 100, and now we have 50, it is now half of, there is now half the amount of atoms because half of them have decayed. This process took 5 minutes. Therefore, the answer is 5 minutes because half the samples of the atoms that we had are now gone. It's gone from 100 to 50, and that's all within the space of 5 minutes. Okay, now this is a tricky concept to understand. Isotopes, radioisotopes, and half-life, they can all be very confusing. So please make sure to ask me any questions, or at least write down those questions for when we have our Zoom class. Okay, hope this video helped you, and I'll see you in the next video.